Hello, my name is Lindy Humphrey, and this is Lab 1 called Charge Tape for Physics 2. To introduce this lab, we are going to discover the ways different charges of tape interact with each other and introduce the idea of charge and property matter, making estimations and assumptions, and finding the amount of excess charge on everyday objects. The materials are listed, as well as knowledge about GlowScript code to create the computational model to compare it to the model that we did in class. And the results, we're going to find the charge for each tape and the number of electrons. Some fundamental principles and models that we'll use is Newton's second law, Coulomb's law, and gravitational force. Their equations are listed on the side, and the reason why we use these equations is to understand the effects of each other and their interactions, so they're very important. The purpose for this experiment is we will create charged pieces of Scotch tape and observe the interactions between them and between household objects. After observing these interactions, we will do experiments to determine how much excess charge is on one piece of charged Scotch tape. There are some pictures of initial reactions before the real lab between the two pieces of tape. We compared it to neutral surfaces, and they were very attractive, such as the desk and the charged pen. And then when we put two pieces of tape that were both charged near each other, they repelled. And this also helped us know that the tape was positive. Some initial conditions. We determined that the tape length was 20 centimeters. The tape mass was 0.2 grams because for tape, the mass is 1 gram per meter, so the mass of our tape would be 0.2 since the length is 20 centimeters. The system is tape B, the surroundings is tape A and everything else, and then the distance between the two tapes is 3 centimeters. Some first questions that we had to establish during that initial part of the lab on the Canvas file is what was the magnitude of the gravitational force on tape B, what was the electric charge on tape B, the number of atoms on the sticky surface of the tape, and the ratio of the number of electrons to the number of atoms on the sticky surface. You can see our work for each of these questions and our answers, and then there is possible sources of error, could be rough estimation, human error, or loss of charge between the tapes due to handling or environment. Then you put it into the GlowScript code to create our computational model. You can see where we put the specific type of coding for the tape that we were using in the code, and then the GlowScript model gave us the computational model of a free body diagram for the tape, as well as the information of electric force field, where they were positioned, and some of the numbers for electrons lost on one piece of tape. Some more assumptions or errors that we had to explain or know for this lab was air resistance and friction are negligible. The long tape is a point charge, and each tape was evenly distributed to charge. Some errors that we could account for is rough estimation, human error, and loss of charge between the tapes due to handling or the environment. Some last questions that we have to answer for this lab is, what if the electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tapes and the other charged objects? The answer to this question is all the observations would remain the same because they are still opposite charges. The tapes would still repel each other and be attracted to the other objects. And then, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with your hands or other objects, or neutral objects for that matter? And the answer to that is the pieces of tape become more neutralized when they are being handled more and more, or come in contact with your hands or other objects because they are trying to regain electrons. So as we began to handle the pieces of tape more and more, we could tell that the charge was just going away because of this reason.